Welcome to the new session of object-oriented programming using C++. The topic of the day is operator overloading. Now, what is the meaning of operator overloading? Operator overloading is a type of polymorphism and is used to give new meaning to the already defined operators in C++ language. Now, polymorphism means many forms. What we are going to achieve with the help of operator overloading is that we are going to give or define or redefine an already defined operator in C++ programming. So first thing is that you cannot overload an operator which actually does not exist in C++ programming. So you can only redefine the operators that are already available in C++ programming language. But what is the need of overloading the operators in C++? Now, every operator has a predefined meaning. For example, a plus operator, which is also known as an addition operator. It comes in the category of arithmetic operators. Now, plus operator is used to find the sum of two numbers. Similarly, the minus operator is used to find the difference of the two numbers, and the multiplication is used to multiply two numbers. But can you apply multiplication on all types of data? The answer is no. You can apply multiplication on float, you can apply multiplication on integer, but you cannot apply multiplication on character data type. There are limitations to the definition of the plus operator, but the job it is performing is according to the standards. Similarly, you have user defined data type like class. You already know that a class is a binding of data members and member functions, and you can create the various objects of a class. Now, what if you want to apply certain operators on the objects of a class? Now, those operators have a predefined meaning and they can be applied on the inbuilt data types. But what if I want those operators to become operational on the class data type as well? So for that, we need to implement the concept of overloading. Give a new meaning to the operators that already exist so that they can be implemented on the objects of a class. For example, plus operator. So you want to find the sum of the data members of one object and the data members of the second object. So for that, you need to overload the plus operator. Now, overloading an operator does not change the basic meaning of the operator. If you redefine the plus operator to behave in a certain different way or to make it operational on objects of new data types, it will not affect the way it originally is meant to work on the data type. For example, the plus operator. The plus operator, as I said, that it is used to find the sum of two numbers. Even if you redefine it with the help of operator overloading to work on the objects of a class, it will still continue to find the sum of two values as it originally defined to do. The second thing, there is no change in the behavioral attributes like precedence, associativity, and syntax of the overloaded operator. Every operator which is defined in the compiler has a certain way of defining the syntax. For example, A is equals to B plus C. You cannot write it like A plus B is equals to C. The value on the left becomes wrong. The plus operator can only be used on the right hand side of the assignment operator. It cannot be used on the left hand side of the operator. So if you decide to overload any operator, you cannot change the behavioral attributes of the operator. So you cannot use a plus operator on the left hand side because you want to overload it. Also, the precedence of the plus operator is less than that of the multiplication. If within any expression you have used the multiplication and the plus operator together, The multiplication operation will be performed first, and then the plus operation will be performed. Addition operation will be performed. It will stay the same even if you decide to overload the operator. You cannot change the precedence. Similar is the associativity. Associativity of every operator is defined if the same operator is used more than once within an expression. So we are able to move from left to right or right to left. That is the associativity. Means the operator on the right hand side will be evaluated first, or on the left hand side will be evaluated first. It will stay the same. So I hope you are able to understand what is the meaning of operator overloading. It is redefining the already defined operators, and in case of C++, we are basically using operator overloading so that we can use certain operators to with the objects. So overloading the operators so that they can function on the objects of a class. You cannot change the basic meaning of the operator, and you cannot change the behavioral attributes like precedence, associativity, and syntax. This is a list of certain operators that you cannot overload. So like in the previous slide, it was discussed that you can redefine the already existing or already defined operators in C++. Still, due to the structural constraints or the struct constraints of the programming language, you cannot overload the following operators. Which are those operators that cannot be overloaded? Scope resolution operator, the dot operator, the ternary or the conditional operator, pointer to the member operator, preprocessor, and the size of operator. So these operators cannot be overloaded. How do you achieve the concept of operator overloading? The operator overloading can be achieved with the help of a special function called the operator function. This operator function is not just any function, it is a member function of a class. So an operator overloading can be achieved with the help of a member function called the operator function. The operator function is member function of the class. Following is the function header of an operator function. So this is how we can write an operator function. So because it is a function, the basic syntax of writing the function will still stay the same. Let's have a look how we can actually write an operator function. So the operator function, just like any other function, will have a return type. Generally, the return type of a function is the object of the class itself, but it can also be any inbuilt data type like integer, float, or character. After the return type, you use the keyword that is called operator. So the first component is return type. The second component is the keyword operator. The third component is the operator symbol that you want to overload. For example, the plus symbol, the minus symbol, or the multiplication symbol, which operator you want to overload. And the last is the argument list, the list of arguments that we want to pass to the operator function. So given below is an example of overloading the plus operator. So here you can see the return type is sum. Sum must be some class. So the return type is the user defined class. Operator is the keyword. Which operator we want to overload? We want to overload the plus operator. How many objects we are passing to the function? We are passing only one object to the function, and the data type of the function again is sum, and sum must be the name of some class. So this is how we can prototype an operator function, and operator function is used to achieve the concept of operator overloading. So we will see how it works, how we can write the programs in C++ to overload the different operators, and how many types of operator overloading can be achieved. So we have two types of operators. We have generally three types, but we will overload two types of operators because the third type of operator cannot be overloaded. The first category of operator is a unary operator. Now, what is a unary operator? A unary operator is one that works on a single operand. Unary operator works on single operand only. Operator function for overloading the unary operator does not have any argument in the argument list. So how do you know that this is a unary operator that you are overloading? A unary operator does not have any argument. So the argument list of a unary operator will always be empty. So let's have a look into the syntax part of it. It contains the return type. It will use the operator keyword. Then you are going to give the symbol that you want to overload, and then you can see that there is no argument in the argument list because we do not pass any arguments in the while overloading the unary operator. So this is an example. We are overloading the minus operator. A minus operator can both be a unary and a binary. An example of a unary binary operator can be something like this: a is equals to minus b. Here minus is a unary operator because it is only operating on b. The next example is a is equals to b minus c. Here the minus operator is the binary operator because it is working on both b and c. So as you can see here, we will see in the next coming slides how we can overload the unary operators. So here is an example of overloading the unary minus operator. We are not going to write the whole program. So you know how to create a class. So you can create a class by yourself, and you can create a class with a single variable. The name of the variable will be var1. And within the class, we are at this moment, we are only going to define the operator function. So the operator function is used to overload the unary minus operator, as you can see here. The name of the class is minus. So minus is the class, as you can name of the class. Return type of the operator function. Operator is the keyword. Minus is the operator symbol that we want to overload, and no arguments being passed. So what we are going to do, we are going to create a temporary variable or an object of the minus class in the line number 1. As you can see, I repeat this here. So this line is used to create an object temp of the minus class. The value of the variable 1, or the value of the data member variable 1, which belongs to the temp object, is equal to the minus variable 1. That means the negative of the variable 1 data member of the object that called the operator function. And once we have stored this value in the variable 1, we can return that value. So let us see how it works. So far what we have seen is only the definition of the function. It may not be so clear to you. So, but the things will become much more clearer when we will see an example of it. Below this highlighted rectangle, these two lines are part of the main function, as you can see. So within the main function, we have written these two lines. The first line is very easy for you. I hope you can understand that. Minus object 1 comma object 2, which means that you have created two objects. So once you have created two objects, let us suppose that you have taken some input for the variable 1 data member of the object 1. So that means, let us suppose that the value of the variable 1 which belongs to object 1 is equal to 5. So somewhere you must have called within your program the input to the variable 1 data member of the object 1 class, which is equal to 5. So this is the most important line in the program, as you can see here. Object 2 is equals to object 1. This is called the operator function call statement. We are calling the operator function. How do we know that we are calling the operator function? Because this minus is the operator function, the symbol that we want to overload, or we have overloaded. Now, which object is actually calling this operator function? The function, or the object on the right hand side of the minus operator, object 1, is the object that is calling this operator function. So operator -1 function has been called by the object obj1. So what will happen? We will jump to the definition of the minus operator. Here the temp variable has been created. Now temp dot variable 1 is equals to minus variable 1. Now what is this minus variable 1 here? The minus variable 1 belongs to the object that has called this function. Now which object has called this function? Object 1. So what is the value of variable 1 that belongs to object 1 is equals to 5. So what is the negative of this? The negative of this is -5. So it will be assigned to temp dot variable 1. So temp dot variable 1 becomes -5. And we are going to return it. We are going to return temp. So once we return temp, where it will go? It will be assigned to object 2. So this is how we can overload a simple unary operator. So next, we will see how we can overload the unary increment and decrement operator. So first of all, you can see the definition of the unary increment operator, as you can see here. And these lines at the bottom, they are part of the main function where we are calling the operator function. So first of all, let us focus on the first line in the main function, that is increment object 1. What is inc? Inc is the name of the class, and we have created an object of that class, and the name of the object is obj1. And then we call the operator function plus plus twice, one using this syntax and the other one is called using this syntax. So both times when we call this operator function, this function will be executed. As you can see here, this function will be called. Now what does this function do? It simply increments the value of the variable 1 by 1. It is very simple. So this is how we can implement it. You can simply create an object of the class, and then through the object of that class, you can simply write the name of the operator. In this case, it is plus plus. But as you can see, we have used two types of syntax. One is called post and one is called pre. The first one is called the post increment and the second one is called the pre increment. But the function called is same for both, which is not the right thing to do. What we want is, we want to write a separate definition for the post increment and we want to write a separate definition for the pre increment. Let us see how we can achieve that. Now here is an example of overloading the post and pre increment operator with separate definitions for the both. As you can see in this example, this first definition, as you can see here, is the definition for the overloading of the pre-increment operator. The second one is the definition for overloading the post-increment operator. And what is the difference between the two? The difference between the two is in the argument list. The difference between the two is in the argument list. As you can see that nothing has been written in the argument list of the pre-increment operator, and int has been written inside the argument list. So this is the difference, how a compiler comes to know while mapping the two member functions with the function call statements, which is a pre-increment and which is the post-increment. Pre-increment does not mention anything and post-increment mentions the int. Now again, let's go to the three statements inside the main function. The first statement, as you can see here, is used to create the two objects of the inc class. And then you have two statements written at the bottom. Object 2 is equals to obj plus plus, and object 2 is equals to obj plus plus. In both the cases, we have called the post increment function. So which definition will be executed? The definition with the int keyword will be executed both times. What if I wanted to execute the definition number 1 for the pre-increment? Then you have to use the following statement. Obj2 is equals to plus plus obj1. If you use this statement, then the definition number 1 will be incremented. Now, what is the difference between the two definitions? The difference between the two definitions is the placement of the return statement. In case of pre-increment, the return statement is written after the assignment statement. So the assignment statement comes first and then comes the return statement. Why? Because we want to return the incremented value. So the increment should happen first, the assignment should also happen, and then should be the return. But whereas you can see in the post increment, the increment is happening in the variable which belongs to the object called, but the assignment has been done to some temporary variable. So two variables have been used, so two objects have been used. One of variable 1 belongs to the object that has called the function, and temp belongs to the variable for the temp object. Now the return statement, please focus on this return statement right here. The return statement does not return the incremented value, but it returns the temporary object in which the value was assigned before the increment. Please look at this. The increment is happening first and then the assignment. Here the assignment is happening first and then the increment. So in first case, because the increment is happening first and then the assignment, the incremented value will be returned. In the second case, because the assignment is happening first and increment after that, hence the non-incremented value will be returned. I hope you are able to understand how we can implement the two different definitions for pre-increment and post-increment for overloading the unary operator. Next, we will see how we can overload the binary operator. Now, what is a binary operator? A binary operator is one that can be that operates on two operands. So a binary operator is placed in the middle. There is an operand on the left hand side and there is an operand on the right hand side. So how the syntax is different from overloading a unary operator? The difference between the two is in the argument list. Because there is something on the right hand side of the operator in case of overloading the binary operator, so that object or that variable on the right hand side will be passed as an argument to the operator function. As you can see in the example here, minus is the name of the class and an object to the minus class has been passed to the operator function. So let us see with the help of a program, a snapshot of a program, how we can overload the binary operator. On the top, you have the definition of the operator function to overload the binary plus, and at the bottom, you have two statements written in the main function. The first statement is used to create the three objects of the add class, and the second statement, which is the most important statement, actually is the operator function call statement. So let us focus on the operator function call statement. So what is the operator function call statement? Obj1 is equal to obj2 plus obj3. So this is the operator function call statement. Which operator we have overloaded? We have overloaded the plus operator. How many objects you can see? You can see three objects: object 1, object 2, and object 3. Because plus is an operator function, so which object is calling the operator function? The operator function is being called by the object on the left hand side of the plus operator. So that means obj2 is the calling function. I repeat, obj2 is the calling function. Which object is being passed as an argument? The object on the right hand side of the operator is being passed as an argument. So object 3 is being passed as an argument. So once this operator function gets executed, whatever value is returned by the operator function, which object will receive that value? So object 3, which is on the left hand side of the assignment operator, will receive the return value. So this will receive the return value. So this is the definition or the explanation of the three operands inside the call statement. Object 2, which is on the left hand side of the operator, is the calling function. Object 3, which is on the right hand side of the operator, is the argument that will be passed. And whatever value will be returned, or the object that will be returned, will be received in the object 1. So once you call the operator function, the execution will jump from this statement to this statement. Now this is the function header. So the argument object 3 that we are passing here, the value of the data members of the object 3 will be saved in the object 3, which is the local variable of the operator function. Do not get confused that these two are the same. The object 3, as you can see at the bottom here, is the local object of the main function, whereas object 3 that you see here is local to the operator plus function. It is not necessary to name it as object 3. This object that you see here in the argument list of the operator function can be named as object 4, object 5, or anything. In this case, we have named it as object 3, but please do not confuse that both of these are same. So once we call this, the first statement inside the function definition to be executed is the prototyping or creation of another object called the temp object. So temp object has been created. So what will be the value of the data member variable 1 of the temp object? That will be equal to variable 1 plus object 3 dot variable 1. So object 3 dot variable 1 is not confusing. It is very clear that the variable 1 here in this box belongs to object 3. But this variable 1 is our confusion. It belongs to which object? When we do not mention or we do not use the dot operator in front of the data member, that means it belongs to the function that has or belongs to the object that has called the operator function. And which object has called the function? This one. So basically, if I want to rewrite this whole statement, it can be viewed as temp dot variable 1 is equals to object 1 dot variable 1 plus object 3 dot variable 1. So once we find the sum or apply the addition to both the data members, we can simply return the object. And once this statement is executed, the return statement is executed, the value of the data members of the temp object will be passed to the object 1. I hope this explanation was clear to you, how we can overload a binary operator, how we call it, how we pass the arguments, how the actual argument is stored into the formal argument, and how the value is returned back. So this is how we can overload the binary operator. So in this lecture, we saw what is operator overloading, why we want to perform operator overloading, which operators we cannot overload, how we can overload the unary operators, how we can give separate definitions for overloading the pre-increment and post-increment operators, and how we can overload the binary operator. I hope you enjoyed the lecture. Please perform the practical to understand the topic more clearly. Thank you.